Godot Card Framework, Introduction, and General Concepts. First thing, please watch my videos at double speed. It will make things faster. If you're not used to watching stuff in double speed, you can watch in another speed like 1.5, etc. So you go to the gear, and this is the double speed icon. You select double speed. Okay, first thing, I'll show you how everything works. So the main two objects in my framework are the card piles and the cards themselves. Those are the two big concepts. I made it so you can create most types of card game behaviors and rules using these two objects, the card pile and the card itself. And they also have different behaviors themselves. So let's say some cards like the sword can target piles. Some cards like, let's say, the shield, they can be dragged around and dropped on a card pile, or if you drop it somewhere on the screen, it comes back to the hand. So let's start with the middle card pile. If I target it with the sword, and let's just drop a shield on it too, I can get them back by double clicking and drawing them. So you can put cards in a card pile, you can draw them from a card pile. The card pile on the left, if I, let's say, drag a sword onto it, it will show it as the top card. Let's say it's placed on the board where you need to place a card for any reason, like let's say in Yu-Gi-Oh! Or Magic the Gathering, where you drop cards, or a trap card, or a card that is face up, or etc. Now I can't put anything else on it. That's a limit I put. You can change it in your game. Once I'll show you how it works in the code. But basically that's a card pile. A card pile can also be the draw pile, the discard pile. Let's say the draw pile, you can't drop cards on it, usually. But you can draw cards from it. Let's say it draws cards automatically at the beginning of the turn, so it will call the function that does this. And you also sometimes you need to view the cards inside the card pile. Let's put, let's say, another sword here. Double click it. That's the card viewer. If you have too many cards, you can click down and you can view the other cards. The cards here, they are disabled. It's the same card object, but they're disabled. So you can view them, you can make behaviors that, let's say, in view only. Like if you double click it, you select it, like cards that bring back cards from the discard pile, or anything like deck editing. Like you can use this card viewer for editing decks, etc, etc, viewing the enemy's deck, whatever. I made it very flexible, so... Oh, and another thing. While in this screen I can still do stuff with the cards in the hand. Let's say I'll drag the shield card toward this the middle card pile, and you see it's gone. And let's say double click it, and it returns. So this can be fixed easily in the hand. Let's go to the hand script. I have disable all cards in hand and enable all cards in hand. So when you, let's say, double click just a second. When you double click to view the cards, you will call this, you will first call the hand, the player's hand, and you will call disable hand, disable all cards in hand. And once you click close, you will call the hand again and enable all cards in hand. So that will prevent the player from accidentally, like let's say, I don't know, do stuff while clicking, and by mistake, you see? Yeah. Do stuff like that. So that's that. The hand itself, it has no nodes, it's just code. It holds the cards in an array. The card pile also has a variable array for holding the cards, usually the card names or the card object. So yeah, I'll show you the card piles and all that in more depth in other videos, but let's show you the nodes. In the card pile you have the main node, which is a kinematic body, and you have the area 2D, so it will detect stuff getting into it, like the mouse or other cards, etc. So it needs to have an area 2D, and the collision shape, it must be called area 2D because it uses it here to catch the mouse focus event, the mouse entered event, and it puts it on the mouse focus variable. It has to be called area 2D because that's how it calls it, using the $sign in node query, or however they call it in Godot. Let's see. And then there's the card pile sprite. The card itself has much more nodes. The one that handles input events is the margin container. I used it instead of an area. It worked. You can also use input events like if mouse entered with sprite, but I chose to use the margin container. So you must have this. Doesn't matter, like if you like make custom cards, you just copy paste all of the nodes. I didn't recreate them. So you have the card container node, which starts at the base of the base anchor point of the whole scene, and it has the card background, the card texture, the card back, the card highlight, which I made not visible. And let's show you the card highlight just for fun. Oh, it won't show it here. Oh, right. The card highlight, let's say for the shield. Let's make it there. You see, that's the card highlight. Once I hover the shield, let's make it less, something like that. So you can use an effect, you can use an animation, but you know, I just made it as an example. Let's say that's the highlight. Okay, so there are the card's attributes, like the card's description and the card's name, and the animation player. There are three animations. Maybe you'll have more, maybe for putting cards on the side. So there's the selected animation. Once you hover the card, it goes up. And then once you're not focusing on the card, it goes down. And when you draw the card, it flips. So the flip animation, it has a couple of nodes here. First for the back of the card, the visibility at the start. Yeah, here it is. At the start it's visible, but at the end of the animation it's not visible. And then the way I flip it is with the scale, the X scale of the back of the card. This thing here, scale X, it's the width scale. So it goes from its default X scale to almost 0, but once it reaches this point, doesn't matter if it's close to 0 or not, it becomes not visible. Let's see. And then I go to the card texture and the card background, and I do the same for both of them. Once the card back is not visible, the card background and the card texture become visible, but their width scale is 0, and then it goes from 0 to its default size. So that's how you do this sort of animation. And for the card attributes, at the start it's not visible, but at the end of the animation it's visible. Let's show you with the shield. I had to, because I changed sizes for the card background and card texture, I had to change the values of the flip attributes. You see, they are different than the other animation. So bear this in mind, that you'll have to like kind of recreate this animation if you want to change sizes. Maybe not. So here you see, once it starts expanding the texture and the card background, you don't see the text. But once it reaches the end of the animation, you see the card attributes visible, goes from not visible to visible. The value goes from off to on. Let's show you again like this, and tada. So the card's data, the description, and the card name is not hard coded. You just write it here in the text field. I decided to do it like that instead of having a huge database of cards, and that way it felt more flexible. Maybe not to you, but for me it's more flexible, creating the cards like this. You can even give it to someone that is not a coder, a designer. Let's say he wants this thing to be somewhere else, so he will put it like this here, right? Well, basically you will have to do it through an easier way to do it will be through the transform, wherever it is. But yeah, I made it like that so anyone can basically create a card with a little knowledge of the Godot editor. Not the code and logic, just the visual stuff. The card background here has a different size. You see, it doesn't take all of the size of the card, it's just the middle of the texture. Texture itself is this. No, sorry. This. And the card back is the Godot logo. Don't know why it's not visible. It's the Godot logo. As you can see, its texture is the Godot logo. And it also has an area 2D, so it knows to collide and interact with other objects, basically the card pile. And it has a line node for, as you've seen, it's the gradient line. That's the gradient with the red, yellow and white. This gradient. So the line start is where the line will start, and the mouse position is where the line will end. Let's say I want it to be like here, right? So the line will start. Oh, the shield, it doesn't drag, so I'll show you with the sword. It has the same nodes. I just copied them from the sword. Let's say start from here. So now you'll see the line will start, you see, from somewhere else, not from the top. So that way you can determine where the line starts without using any code. So the card object itself, it has like about 180 lines of code, does a lot of stuff. But the shield card, it expands all of its behaviors and changes just a few minor attributes and extends one method. That's it. We change the name, we make can drag true, so you can drag the card. In the sword, you see can drag is false, so by default, if you can't drag a card, it will use the targeting line to target. So basically, you're saying here this card targets stuff, and here we say that you can drag this card around. And here you see the card's attribute, we change the defense to 5, and here the sword strike, its damage is 5, and the do card action custom is run on a card pile that activates the card's ability, the card's action. So it will call at the end of its logic, it will call do card action custom, and then you can do your code. So in the case of the shield, we will basically call the player and add 5 defense. Or if it's like something that breaks the shield, we will reduce the player's defense by 5 by the defense. And I also called the default init ready of the card script, of the default card script. For the sword, let's say we want to damage the card pile. Let's say it's an enemy, right? The card pile is an enemy. Let's say the middle one is an enemy, so we will we will just edit a couple of its attributes. Can be targeted, can drop card will be like off, and can add cards will be off, because we don't want to put cards on the enemy card pile. We just want to activate the card's ability once we drag it on the card pile. So let's say we drag we target an enemy with the sword card, so the card pile will pass itself as the target, and then we'll check like if target has method take damage, and then we'll pass to take damage the damage we want to do to it, the damage attribute. So we'll do it here. So that's kind of the idea of how to use damage cards. I will in the future create examples of how to practically use it, but basically I wanted to make a modular system that can be adapted to almost any game that needs this sort of functionality. Like let's say in your game the shield goes sideways, right? Like you flip it to the side to use it or something. You'll have to add an animation that will be called flip to the side, and when let's say the player clicks on it twice, it will play the animation of flip to the side, and at the end will do something. And also, as you notice, you don't have to deal with too much code. Like most of the logic of the GUI and everything is done in card. Even when in the card viewer, it will let's say the card is in the card viewer, it will change it to view only. To do that, let me show you. You see, it sets the view only to true, and that way, when it's in the card viewer, it doesn't do all that, because it exits the process here, so it doesn't run these. And that way you can do custom view only for that screen. And like, let's say it's a deck editor, so you'll put the deck editor component here, and that way you can manipulate the cards in the deck editor. So it's just an example of how to use my framework for that sort of stuff. In the next videos I will go more into depth about the code of the cards. As I said, it's about 600 lines of code. The card has 200 lines. The card pile also has about 200 lines. The card viewer, not so much. About 100 lines of code. And the hand also, it has 100 lines of code. So I'll make a video for each, and I'll also have to show how they work together. And that's it for now.